Hello, students. I am back with yet another topic of chemistry from class 9th, and that is going to be atoms and molecules. So today in this chapter, we'll be dealing with laws of chemical combination. So, what do you mean by laws of chemical combination? I'm sure you have a little bit of idea from, your previous sessions or classes. And if not, then today we are going to study about that. So, these laws were made to understand the chemistry of any substance or any kind of reaction in a better way. Okay, so we wanted to come to a conclusion that how a pattern is being formed during any kind of chemical reaction happening. Okay, now what exactly the law of conservation of mass states? First of all, it was given by Antony Lavoisier. Okay, he was a French scientist, so we have to pronounce the name like that. Now, law of conservation of mass. Mass can neither be created nor be destroyed in a chemical reaction. What do we mean by that? So, for example, let's take a reaction A plus B combined to form C plus D. Okay. Now, maybe these two combine and formed A plus B is equals to C. Or maybe they broken down into C plus D. But what it says that if A is 10 grams, B is 10 grams, C is 10 grams, and D is, has to be 10 grams. Or maybe C can be 5 grams and D can be, let's say, 15 grams. Okay, this is 5. So anyhow, if you will add the or do the sum total of reactants, okay, the total mass of the reactants, all the reactants present would be equal to the total mass of all the products. So here you can see, for example, here, if we add them, it will be 20 grams. Right? And if here also you'll add, it will be 20 grams. This also will be 20 grams. Now, for example, here in this reaction, let's say these two combine together to form only one substance. Then also this is going to be 10 grams, 10 grams. Then C is going to be 20 grams because the law of conservation of mass says that if we combine or if we sum total of the mass of all the reactants, it will come out as equal to that of the total mass of all the products present in the chemical reaction or formed during the chemical reaction. Here the energy would be gained or energy would be lost. Okay. So in a, very depth, if we look at this, then also you'll understand. So for example, let's not take A, let's take this reaction. Right? So here two hydrogen hydrogen molecules combine together to one oxygen molecule to form two water molecules. Right? So here whatever or how much ever you have taken hydrogen, that is going to be hydrogen molecule. Hydrogen molecule, hydrogen molecule. And we know atoms cannot be destroyed. Then it will lose its essence. Okay. And this will be made up of oxygen atom, this will be made up of oxygen, right? Like this. Now, this can rearrange to form, like these two hydrogen can go with this one oxygen, and these two hydrogen can go with the other oxygen to form new one and something new. Okay, but the things which are forming, or you can say the elements which are forming, or the atoms of those elements will remain same, and hence the mass would remain same. So I hope you understand the depths of this concept, why and how it came from. Okay, so now moving ahead. So Lavoisier was the one who actually proved this by having or conducting an experiment. What the experiment was? The experiment was he took a tin, okay, you can say a tin container, and in that it was filled with gas, nothing but gases. Now that gas has oxygen as well. Right? So first what he did was he just simply weighed, okay? He just simply measured the mass of it. And after that, what he did, he started heating it. So once anything is being, heated, it reacts. There occurs a chemical reaction. We have read about this in the previous sessions, right? The physical and chemical changes. So we know if anything is being burnt, so there is a chemical reaction or chemical change we usually see, right? So this is oxygen and oxygen reacting with tin due to the presence of heat. So tin oxide would be formed, right? But that now again, when this will be weighed, when the product is formed, again the mass remains same. The observation was that the matter was neither lost nor gained any kind of, mass, right? So that means there is conservation of mass is there in any sort of chemical reaction. Now, some amount of mass can be lost, like, for example, we were taking 10. Okay, let me just change the color, that would be better. So we were talking about this reaction, right? C plus D. So here 10 grams, B is also 10 grams, right? So if we are getting this as 5 grams, maybe we can lose some mass and get 14.5 grams or 13 grams. Why? That some mass can be lost as, you can say as smoke or anything. If you are doing a proper setup, then you will be able to conserve the mass. Okay. So for that, you'll have to, have a setup where you can convert this steam also into, or the the vapor also into the form where you can weigh it or not lose it, basically. Now, another law is law of constant proportion. This was given by Joseph Proust. So, the first law of conservation of mass was given by Lavoisier, and this is given by the Joseph Proust. So, okay. Now, he said a chemical compound always contain same element. The one thing which we have to notice, and in the same proportion. That means, for example, we take water. Okay. Now, what we were saying like each time is that water is made up of 2 hydrogen atom and 1 oxygen, right? Now, the elements will always be same. For example, here you cannot put carbon and still get water. Then it won't be water. Then the properties of that compound would change and it will become something else, right? So we have to have same elements. The second thing would be same proportion. That means it is going to have same proportion, means that if there are 2 hydrogen atoms combined together to form water, then there has to be 2 hydrogen atom wherever you take water from. That doesn't matter. Like, for example, if you are taking it from a river, bubbling river, if you are taking from the vast ocean, any part of the ocean, right? If you are taking it from gentle rain or maybe your simple tap water. So every water present everywhere will be in this form only. That means only hydrogen and oxygen will make more water, and also hydrogen will be combined in the form that hydrogen will be having 2 atoms and oxygen will be having 1 atom. So the ratio or the proportion should be equal as well. Okay. Now this law tells us no matter where a pure chemical compound comes from or how it's prepared, its elemental composition is going to be same and the mass will be, same always. So suppose, not suppose, it's actually like is the case that water has around 11.1% of, hydrogen by mass, and oxygen has 88.9% by mass. So these two combine together to form water, and water will be having 100% of these two things, okay, combined in different ratios, obviously. So that is the law of constant proportion. So Proust, what he did, how he actually managed to reach to such a conclusion is basically he took pure samples of water from everywhere, almost, from all the origins and different places he took the water, and he got to know that the mass of the hydrogen everywhere was the H was around 1, right? And oxygen, what is the mass, atomic mass of oxygen? That is 8, right? So from wherever he took water, the mass was the ratio of the mass of, hydrogen and oxygen would stay the same, and that is 1:8. And then he proved with that, in his mind that elements within a compound combine in a very fixed proportion. It cannot be like 2 grams of or 10 grams of, hydrogen and maybe only 2 oxygen. Okay, 2. It will come boil down to, let's say, 5:1. No, it can't be, right? So that is the case. Now, the what we have studied so far, to summarize that, so we have studied conservation of mass, we have studied constant proportions, that the element, the proportion is the same ratio. Okay, the element would be in the same ratio basically, right? So this is all we have studied so far. And then coming to the questions. So to test your knowledge, you can try solving these questions. The first one would be, who proposed the law of conservation of mass? So is it Dalton, is it Proust, or is it Lavoisier? I'm sure you are sure with this because we have discussed in the first or second slide only. Now, coming to the second one, in water, the mass ratio of hydrogen to oxygen is 1:1 or 8:1 or, okay, here has been a mistake. This was supposed to be, let's say this one is 1:8, okay? My bad, right? So now you can answer. And which of the following is not true? Mass is conserved during chemical reactions. Elements in a compound are always in fixed ratio. Ratio of elements will varies based on the source we have taken anything from. Okay, so this is all for you. I hope you'll try to answer this in, comment section, and I'll, let you know whether you are right or not. And hope to see you in the next session. And also, if you want to study more, you can contact me through my Urban Pro profile. Okay, thank you so much. Bye-bye. Take care, everybody.